And just to jump in, just to remind people that we will be recording this workshop today, which will then be hosted on YouTube in an unlisted channel, so that people who are unable to attend the workshop will be able to access this video and materials. Thanks.
Okay, I guess then I can start. I will just quickly share my screen.
Just
Okay.
Just before you do that, there's the results from the poll. I don't know if you can see these, Johannes. But so we generally have 15 people running Windows, 4 people running Macs, 3 using the Docker, 2 using RStudio Cloud, and a couple of people who will follow along just using the PDF. And then, yeah, like Robert said, GLM is the most popularly used model, and there's a lot of people here who have varying or people who haven't worked with models before, which we're also eager to kind of introduce these models to people. A couple of people had some troubles with installing our packages, and we hope by the end of this to maybe provide some information on how to do with those. There's a couple of people here that have selected Python as a coding language, which we will be removing these people from the workshop accordingly. And yeah, so we've relatively intermediate levels of R. And then lots of people are interested in applying this to their own Lake system, which is very interesting to see. And people are interested in getting involved in further developments and to learn about the models. So that's
very nice. Okay, should I start? Do you want to start recording?
Yeah, it's recording.
Okay, perfect. So then, welcome everyone from my side. I'm really happy and excited that so many of you are interested in our workshop and also came to our workshop. I would like to start by saying that the LakeEnsemblR project is a collaborative project from members of the GLEON modeling working group and the EMONJ network. And start by introducing the team. Rosie already introduced the 4 of us, so there's nothing more to say, just a few new nice pictures of us. And then I would also like to say that we are, of course, the LakeEnsemblR is a bigger team. There's also Freya, Rachel, Tom, Jason, Austin, Hillary, Kevin, and Jordan. And some of them are also in the workshop here today. So that's very nice. And we are happy that you are here. Okay. So welcome everyone again. If you have any questions during the workshop, feel free to ask them at any time. Robert and Tadhg will try to kind of keep watch on questions, and if I don't see them or later Jorrit doesn't see them, will remind us. So you can just raise your hand in Zoom or just write the question in the Zoom chat. And if you have questions after the workshop, you can either use the GSA Slack channel, which we have also been using before for communication, or you could join also the EMONJ Slack channel, which we have been using during development of the LakeEnsemblR package. And to join the EMONJ Slack channel, here is a small QR code on this slide, which leads you to an introduction. We already sent out an email and also wrote this in the Slack channel again. And I hope everybody has already prepared the necessary software. There are different ways you could follow this workshop. If you want, you can also just sit back, listen, ask questions, and continue with just discuss with us. Or, of course, you can follow along in large parts of the workshop. We will do hands-on code, and you can either using your R installation or the Docker, or something that is not on this list here, the RStudio Cloud, which Tadhg made a very nice video how to use it. Okay, so the time schedule of today is the following. We are now in the introduction, which I will be doing. We will quickly talk about why we think we should use ensembles. Then I will give a short introduction to the LakeEnsemblR package. And then the main part for today will be a hands-on practice where Jorrit will lead you through a script which we prepared, go step by step and explain to you how to set up LakeEnsemblR for a lake. So we will go through the input files which we need. We will explain the functions. We will show how to visualize the output. And then if there's still some time at the end, you can also try to apply it to your own lake, or we have some example lakes prepared. And then the last 15 minutes, we would like to have a discussion together with all of you how we could continue with LakeEnsemblR. So what could be applications of this? How could it be enhanced? What would you need to use it for your lake system? Okay, let's start with the motivation. So as probably lots of you know, there are lots and lots of different one-dimensional models out there for lakes. There are also two-dimensional and three-dimensional, but we will stick to 1D for now. Here are some examples: FLake, GLM, Gotham, and there are lots and lots more, and they all have different requirements. So some developers provide already compiled executables. Some of these models have very nice handbooks. Some have not so nice handbooks, or it's really hard to figure out how the input files should look. And in our experience, because of these reasons, people that start modeling tend to use the model that their lab or their supervisor is using, and not the model that is maybe best suited for their case, if there is such a thing. And then, of course, instead of just using one model, there's also the possibility to use more than one model, which is called an ensemble. And we have here on the slide this nice webcomic from XKCD. So an ensemble is basically a set of different model runs, or which use either different models or the same model with different parameters or forcing data. So you get several different simulations for your variable. And this then gives you also an idea about the uncertainty, or you could compare the different models and see which one has maybe the best or is best for your application. In other disciplines like climate modeling or weather forecasting, using ensemble is state of the art already, but in lake modeling, this has been not done so often. So in the last few years, there were a few very nice publications using ensembles, but it's still rather rare. And this is why we thought we could maybe help people to use more ensembles, and developed the LakeEnsemblR package. So as we already said in the title, we created an R package, which at the moment contains 5 different one-dimensional lake models. And these lake models are all contained within their own R packages, which just contain the executables for Mac, Windows, and Linux, and a small function to run the model in the R environment. And then we came up with what we think a quite nice and convenient workflow how to use this. And this is shown here in this graphic, where we can see the most important functions that are contained within LakeEnsemblR, and also the folder structure which a LakeEnsemblR project has. So we have this main directory, which is, for example, for your lake, which you want to model, the directory, and within this directory we have the configuration file where all the information about the lake are collected, also about the numerics, the time step, and so on. And then all the necessary forcing data to run this. So the meteorological forcing, inflows, light extinction if you have time series for this, otherwise it can also be constant, a hypsograph, and of course observed data. And all of these need to be in a standard format which we defined. And then you can use the LakeEnsemblR, the function export config, which is here shown in black at the top, to automatically generate directories which contain the model-specific data and configuration files. Here, these model directory A, B, and C, so they have the same name as the model which you would like to run. And this is done automatically, so the config file and also the forcing files in the required format for each of these models. And once you've done this, you can use the run ensemble function, which is here in the middle in blue. And this will just run in the directory and then compile one output file and save this in a new directory, which is called output. Actually, it can also be several files. It can either be a netcdf format or in CSV, but we will go into this in detail during the hands-on part, create one outcomes from the different models. And if you want to calibrate the models, there's also a function which is called caliensemble here. And what this is doing, it's running the models, compare in a new directory, doing this over and over again, depending on which you used, and then at the end you get the results in this new directory. And then we have functions for post-processing. So we have functions that can be used to evaluate the model performance, which is here this calcfit function. We have a function to calculate some. Then we have functions to visualize the results, both the results of running the model and the results of the calibration. And we have functions where you can load the results from running the model ensemble in R quick, but we will go through all of these functions in the hands-on part, which will follow next. So the five models which are currently Mike of their functional lake models that have different. I don't think here we need to go into details, but if you're in the discussion. And we have 3 different methods for calibration. Actually, it's more than 3, but I'll come to this in a second. So we have a Latin hypercube sampling method, which is basically just sampling a given number of parameter sets in the parameter space and then running the models for all of these parameter sets, calculating model performance, and then you can take the set of parameters with the best performance. We have a Markov chain Monte Carlo algorithm, which is a Bayesian method, which also gives you a distribution of the parameter. And if you have more than one parameter which you calibrate, you also get some correlation between the parameters. And then, this is why I said actually it's more than 3, we have a method which can be used to run, I would say, a standard optimization algorithm like Liebenberg-Marquardt or something else. So this is just an implementation of the modfit function from the FME package. So it's an R package by Sortet and Petzold. And this has different optimization algorithms, and you can use any of those. Okay. So this is just a rough overview. As I said, we're going to go into detail in the main part of this workshop. I just wanted to say that if after the workshop you need some additional support, all of the LakeEnsemblR code is posted on GitHub and also have a vignette, so a document which explains a little bit more in detail all of the functions and also has an example which you can read. Then on this GitHub page, we have a wiki where we have a part with FAQ, so frequently asked questions. GitHub repository where we have 5 different example lakes, which you can see here in the right top, which are already in the right format, and you just can download it and run LakeEnsemblR and then explore it a little bit on your own. And I would like to say here at this point that we would be really, really happy if you try it out on your own lake and play around a little bit. And if you find any bugs or problems, just contact us. And this also really helps us. Or if you say, okay, this is really nice, but I would like an additional feature, we are also really nice. We are really happy if you contact or if you even want to contribute. So this is an open project, and everyone who wants to contribute is more than welcome to contribute. Okay. So a quick thank you, of course, to our funding agencies at this point. And now it's almost time to go to the hands-on part of the workshop. So we already said this in the beginning and also in the email which we sent and in the Slack channel, but I wanted to remind you again, all of the workshop material is available on the GSA GitHub repository. You can see the link here. We also sent the link in the email, and it's in the Slack channel. And also this presentation, which I just gave, is available on this GitHub repository. And for the hands-on part now, we prepared a script, an R script, which we will go through step by step together now. And actually, this here is not correct anymore. We actually have 3 different versions of this script prepared. So a PDF file, an HTML file, where we have the R script and some additional explanations and text, and then one R script which has just the exact same R commands as in those 2 documents and some really short comments. You only need one of those 3. You can pick whichever you prefer. I personally would recommend to use the PDF or HTML and copy and paste the R commands to a new R script and write your own commentary so you can remember again what is happening, but that's just my preferred method of doing it. Okay, so before we really start with the hands-on part, I would take a short time and ask if there are any questions so far. Doesn't seem to be the case. Oh, there's something in the chat. Okay, so Tadhg just posted the link to the workshop material. So everyone who has not downloaded the workshop material so far, you can download it now. Also, I would like to say that in the last few days, there were really small changes in the presentation slides. And so if you want to make sure that you have the latest version, you can download it again, but the scripts have not changed. So okay, there is a question from Sophia. Are you planning on including more lake models into the lake ensemble? That's a good question. And yes, we are planning to introduce more models. We are currently talking with 2 model developers. The one is called Air to Water, and the other one, I always forget the name. Can someone help me from the team?
ALBM.
ALBM. Yeah, so we would like to include more models.
So just to add, maybe if you want to add your model to LakeEnsemblR, just contact us and we can then add it to it.
Yeah, so if you're a model developer. Okay, then I would like to thank you for your attention for this short introduction and give over to Jorrit, who will go through the scripts. And maybe one more thing, during this hands-on part, Tadhg, Robert, and I will be available. So if there are really major technical issues, we can also open a breakout room in Slack, and then we can go quickly into this breakout room and try to help you solving your technical problems. So whenever you feel like something is not working that should be working, just contact us and we will try to figure it out. Okay, Jorrit.
We just got another question there from Jim Ruzek. He says, previous experience suggested there is a fair bit of tweaking needed to be happy with a model. How is this handled here?
So we have more or less standard parameterization for the 5 models we have so far. And during the setup of these models, these standard configuration files are copied. And for the different lakes which we tried out, we had different experiences. So you're perfectly right. So for some lakes it worked quite good. For others it didn't work really well. And then because all of, or at least some persons in the team have worked with the different models, we have an idea of which parameters are good to calibrate. And then, yeah, so this is why the calibration function is also in there. And also this worked differently well. So for some lakes, we have really, really good results, ones not so well. Okay, I hope this answered the question. If you like, we can also later at the end have a little bit more discussion, because I think this is a really interesting topic. Okay, Jorrit, then I would stop sharing my screen and give over to you.
Okay, thanks, Johannes. Let me share my screen. So now you should be able to see it. So now we go to the hands-on session. This is the link that Tadhg just shared. So as Johannes explained, you can participate by using either of these files, which so you should have cloned this directory on your PC. And you can follow along basically however you want. I will be slowly running through this this R script, and hopefully giving you some time to follow along if you want this. So here I have my folder, and here is the R script which I will open now. So if you can also open it in RStudio.
Jorrit, could you mind just quickly showing them how the HTML looks and how the PDF?
Of course. So I will just open the PDF for now. So here you see the PDF. We have put several comments. Basically, all the information you need is in here. So also for future reference, you can use it. The second part deals with the installation and loading of the packages, which we will do not do here, as it was part of the preparation. And we will basically start our R script here. So how to load an example setup. And these lines of code are pretty much present in the R script we also uploaded. Or as Johannes said, you can copy it to your own script. So if everyone is ready, we first, before doing anything, we set our working directory. This part over here, if you're working in RStudio, sets the working directory to the directory that your file is in. However, if you do not work in RStudio or you want to use a different folder, that's possible. So you can also copy the path in here if you want. On Windows, remind to paste with // Another part of the preparation is that we set our time zone to UTC. We realized that some people, the local time zone was not really recognized by our functions. So this will avoid any issues. I also usually do this in my workflow. So as you saw before, we have just an empty directory. What we will be doing now is we have set up an example. We have example data for a lake in Ireland, Loch Fia. This is located in the package. And with these two lines, we will copy this to our own working directory. So we locate the folder where the example is located, and we then copy it to where we set our working directory.
Jorrit, would you mind opening the Files tab in the file viewer in RStudio? Yeah.
Okay.
So, just so people can see that's where it's going.
Yeah. So here there is a FIA folder, and we will set our working directory there. I guess I have to click here. And the next step would be loading the packages that we will use in this workshop. If you work with LakeEnsemblR, you will only need to have the LakeEnsemblR package, but we will apply some other plotting functions. I think most of these packages are packages that LakeEnsemblR relies on, so you should already have them. So the first part is, I think, quite important that we have a look at these files that we have in our directory. So you can already see them in the files plot. We have 6 files, and essentially all of them are lake data. So we have a file with meteorological data, temperature observations, inflow, bathymetry, and then we have the LakeEnsemblR.yaml file. And this is sort of the key configuration file of LakeEnsemblR. Here we have almost all the information that we want to include. And this has been already set up for LogVIA. So we have the latitude, the longitude. This is information that many of the lake models need. And by putting it here in one centralized location, we can sort of transfer that later with the export config function, as we will see further down. And in the second section, time, we also say we will be running basically over all of 2010 with a time step of 1 hour. I will not go through the whole script, but to quickly mention, this config files section gives links to configuration files of this model, the specific models that we want to run. These files do not yet exist. If they do not exist, we will copy a default template from the LakeEnsemblR package. And further on, you can also give links to files that we need. One thing to specifically mention is, for example, here the meteorological file. As you probably know, meteorology is the main forcing for your lake model. And actually, if we have a quick look at the CSV file, I will open it in a text editor. You will see that this format is very, we use it for almost all the input files. We have comma delimited columns over here. If there's a date time involved, we have it in this format on the left, and then all the other columns are comma separated. And you may have noticed that we only give one link to the meteo file. You do not have to say in what column is what information. That is because we use very specific headers. So here we have 10 meter elevation wind speed, meter per second. We have air temperature Celsius. And what the package does, it reads these headers, and therefore it knows that you have provided this variable.
Jorrit, we just got a question there from Jim. He asked about the ice height in the YAML file.
The ice height, yes. So that's something that, sorry, I have open here. You can provide observations. In this case, we have provided observations for temperature in this file. Actually, we have the file, we could provide it, but because we have a lake in Ireland, it's always 0. So in this case, we have not entered our observations here, but you could enter observations of ice thickness. About these column headers, it might be difficult to figure out what is the right column header. We have a variable in LakeEnsemblR, a dictionary, Medvar dictionary. So if we run here, you can see all the potential column headers that you can put there. So here we have, for example, our wind speed or air temperature. And we hope that this, on one hand, makes it a lot easier to structure your workflow. You only have to give one file name, and also because you have to consciously enter the units, we hope there are less mistakes regarding the units. So I'll wait a little bit for everyone to catch up, to read the text in the PDF for the HTML.
Jorrit, maybe you can say something about the sub-daily time steps for the models. So can you run LakeEnsemblR on a sub-daily time step?
Yeah, so in our current time step, in our current setup for Lofia, we are using hourly time steps, which and now we're getting a bit to the why is it complex to run these ensembles? Because we have one model, MyLake, that for example runs on daily time steps. So in this setup, we will be using hourly time steps for models, and we will average the daily time steps for MyLake, for example. So this is all handled by the package.
And just a question on meteorology. What about if you have NAs, or what should people do with missing values?
So as I think in all the models that are here, you cannot have NAs in your forcing data. I'm actually pretty sure that your model will, that LakeEnsemblR will throw an error quite early and say that you can't have this. So if you have missing data, you should linearly interpolate this data before using the package, which I think in some of the models automatically happens. So this is now our folder. We have all our standardized input data and observations, and we have our configuration file. So this actually is everything you need to run LakeEnsemblR. So we can now start with the first key function of the package, export config. So all our functions have a help page, which you can access like you would access any help page in RStudio. You have a question mark, and then you type the function name. So this is what we see here in RStudio. And the config file, the export config takes as arguments the configuration file that we have, and then all the models that you want to do it for, to export your configuration settings. In this case, we will use all the 5 models that are currently in. And you are able to switch off parts of these functions. For example, if you have already run it and then change light extinction, you can only run the light extinction part, but we will not touch this here. And you also can give the folder where you want to run this function, but we will run in our current working directory, so we don't use this. And this function will export all the settings in our input and configuration file to the model specific folders. So I think it's most clear if I just run it now. You see a lot of messages of things that are being changed inside files. You see that now meteorological files are being created. And we're done. And now if we look in our files folder over here, you see we have 5 new folders. So 1 for every model. And then if we go into one of these folders, I'm not very at home with this format. I will just use, in my case, Windows Explorer. If we go to the GLM folder, I think this will already look very familiar to people who attended yesterday's workshop. We now have also a GLM configuration file that is needed by GLM. So we have the setup, and here we have either the default settings or settings that we entered in our LakeEnsemblR main configuration file. So we have the same start date, same stop date, time step. We have converted our bathymetry to the format required by GLM. And if we, and also a meteorological file, which looks slightly different for GLM. It has been converted to the format that is needed. And if we go to, for example, the Gotham folder, we have a different setup, which is needed by Gotham. This is the Gotham YAML file, which has completely different setup than GLM, but this is taken out of your hands and is done by LakeEnsemblR. So as Johannes said in the presentation, LakeEnsemblR cannot actually run these models. There are several of the submodels that you have installed before this workshop, Flake R, Simstrat R, Gotham R, that have the executables. And you could now go to each of these folders and run that model in that folder. So if the Simstrat folder is completely set up to be run by Simstrat if you have the executable. However, that's of course not very efficient, and we have the run ensemble function that does this for you. So first you need to run export config to create all these folders, to get your settings in those folders, and then you can run ensemble. As we put in the PDF or HTML, there is something that may interest you, and it relates a little bit also to Jim's question at the start. There are several specific settings in some of those models that you might want to change as well, some very detailed things. Some are just parameters. In the LakeEnsemblR YAML file, we have a model parameters section, and you can just enter a parameter for that model and give it a value. For example, I could just enter here for Simstrat. I need to give 3 spaces and an AC is a parameter that is important for Simstrat, and you can give a value here and it will be translated when you run export config. So this is one way to do this within export config, but some settings are maybe more complicated than just a parameter. Another example for Simstrat is that you can regulate the depth of the inflow, which you need to change inside an inflow file. So we do not support this yet in LakeEnsemblR, but you can write your own lines of code that do this, and you can do that in between running export config and run ensemble. We will not do it now, but this is possible. You have all the functionalities that the models offer. That is just still there.
And just as an example, what you could do is, like, for example, if you had a glm3.nml, so a GLM configuration file that you know works well for your Lake, you could navigate into the GLM folder and copy and paste your GLM configuration there if you wanted to use your already best configuration file.
So because we've now run export config, we're set to run all the models. So let's do that. Just run this line of code. Actually, before I do that, quickly have a look at the help file. Again, it takes the configuration file and the different models that you want to put in. It has several default arguments over here that we will, some of them we will treat during this workshop, but we can quickly forget about them now. So we enter our configuration file and we enter all the different models that we want to include, which is all of them. So we run, you get different messages when certain models are complete. Flake, GLM, Gotham, needs to interpolate, Simstrat's done, and now it's running MyLake. MyLake is a bit slower than the other models at the moment, but it will finish soon. We're only running 1 year, so it shouldn't take too long.
This is also the point where you'll figure out if your installations have worked or not. So if you run into issues, or if you got an error when you run this, maybe put it into the chat and maybe we can help troubleshoot. But or maybe wait till the end. Sorry, wait till the end, and then we can try and help you.
Well, you can always put it in the chat, I think, but yeah, for some complicated things, it might not work yet. But if you ran the test before workshop script, this should work. So what this function has done, it went in every folder, and if we go there to, for example, Gotham, there is an output folder has been created, and there is, in this case, an output.netcdf file, which is the output at Gotham, gives output in for Flake. We also have an output folder. There's a data file, which is just a text file with all the output. And all these output files have a slightly different format. which is why we now also have created an output folder in our main directory, which now contains a ensemble output.net CDF file. And it's in this file that we compiled all the output for temperature and ice thickness, which is what we asked for in the configuration file. But so there is more specific output for some models. Actually, if we look at Flake, this is just looking at the Flake output file. You see it has several, I think this means something with convection or heat fluxes. This is not compiled, but you can still access it. So if you want to access these files, you can. And now we will have a look at the output.net CDF file. So I'm now using a program called PyNCView, which is a Python program to look at netcdf output. It's not a problem if you don't have this. We will later show you how you can load this output into R as well. There are multiple ways for that. And we forgot about the member thing. We do that later in the workshop. But here you will see output for the Flake model. So this is water temperature. This is for 1 year. Now we click, we go to GLM. We go to Gotham. Now we go to Simstrat, which the model has a small bug that temperatures near this sediment can be a bit unstable. So we quickly have to change our temperature scale to a realistic gradient. But you see Simstrat has also reproduced the thermal pattern over the year. This is my lake. And the last is observations. Observations are also included in the netcdf file. You can also access ice height, but that's, as I said, not very exciting as there is no ice. So the reason that we got netcdf output is because in the LakeEnsemblR.yaml file at the output section, we have put that the format is netcdf. The netcdf file we chose for this because everything is in one file and it's very structured. But there is also the option to generate text output, which we can quickly do as well. At the same time, we will introduce the input YAML multiple function, which is inside the LakeEnsemblR package. And what it does is we give the name of a YAML file, and then we say the key 1, the first key is the output, second key is format. So essentially, we're going to change this value, and then we'll want to set it to text. So if we run this line, and we check in our YAML file, it is now set to text. And then if we run ensemble again, it may not be too exciting as it's quite intuitive. Now we will have text output files over here. I can quickly show you how one of those looks, for example, for GLM. It's the same format as we had before, except that now on the columns is WTR underscore and then the depth of, in this case, water temperature. It's the temp file for every depth. And this is the format that is also used by the LakeEnsemblR package. So you can integrate it quite easily.
The Lake Analyzer package.
Yes, you're completely right. Lake Analyzer. We will, however, set the output back to netcdf, as all the LakeEnsemblR post-processing functions will be using this. So we don't really support any post-processing of the text files, but it's probably a lot easier to access if you are not used to netcdf. So this is what we will use and do in this line. We will set it back to netcdf.
We just have a couple of questions there, yours.
Sure.
So one is from Carolina, which is, why is it necessary to convert netcdf into CSV?
It's netcdf is a format that is very compact. You can get quite a lot of data and compile it in relatively little space on a structured manner. But it can, well, if you're very comfortable with it, you can actually quite easily read the data from it. This is more to have an alternative for people that prefer to work with text files. So it's not required. I would say try to work with the netcdf file, as we have these post-processing functions that can help you with it.
Yeah, and just to be clear, it's not converting the netcdf into CSV, it's taking all the model outputs and writing into CSV. So you have the option of creating netcdf or CSV. And then a second question from Kong, which is, he's wondering if the water level change would be included later, because he's using GLEON and he seems that it can include water balance, but not as straightforward as others like GLM.
Yeah,
maybe.
So,
sorry.
Yeah, well, actually, I don't know what you were planning to say, but water level is a bit complicated with these models, as we have 5 models and they literally treat it in 5 different ways. So at the moment, varying water levels are not really supported by LakeEnsemblR. There are no functions that can that allow you really to vary water levels. You can still access all the files, so you can do it yourself. But to give an example, Flake does not allow varying water levels. Simstrat does, but I don't think it includes precipitation fluxes, but GLM does. So this was the reason why it is not included in this version. However, if you want to, you can still change settings, so you are looking at water level changes. But I'll warn you already, you will not get the same water level for every model.
And yeah, but his question is, will it be included later as well?
Well, we recognize it can be a very important part. So we would definitely like to, I think, but any help would be appreciated. So this may be something to discuss at the end of the workshop.
And then just another quick question here we have from Michael. He's asking, can we recommend best practices of what to do if your input data may be at different time steps, especially if NAs are not accepted? Like, would you recommend keeping hourly data as hourly and then having repeated hourly values for another variable that may have been collected at the daily time step?
Yes, so I think I know in Gotham it is possible to have this varying time steps. What Gotham would do is to linearly interpolate your daily values to hourly if you use an hourly time step. What I would advise, definitely this is something that people may agree with me upon. So definitely Tadhg or Robert, you can also speak up. I'd say wind and air temperature are maybe most important. So if you have those at hourly time steps, but maybe rainfall or cloud cover at daily, I would just use hourly and interpolate them. It depends a bit on your data and what you want to study, I think.
Yeah, I would agree. I mean, it's a difficult question because, like, quite often you don't have all the variables measured on site. So it's either looking for ways to either use data from nearby sites or, doing things like linear interpolation. That depends on the user, because some people would never feel comfortable doing that. So, but we would kind of recommend, depending on the variable and the gaps, that linear interpolation can work for some variables, but then other things, maybe it would be better to try and source it from nearby weather stations. So things like maybe precipitation or wind speeds, which are kind of those kind of fluxes, and radiative fluxes, would be better to source from nearby weather stations if possible, or using weather reanalysis data as well.
And just to add, if you use like daily data, some models also will use not linear interpolation, but some kind of curve assumptions like GLM to get like hourly data. So if you use daily data, but on an hourly time step, you can get huge differences between the models for the hourly results. Because I think GLM does not use a linear interpolation, but it takes like a curve to have like peaks and everything on a daily basis. So probably the results will be different than Gotham, I would assume.
Well, I think that's also part that you try to catch with this ensemble approach, right? Like all the models, as we will see now, actually, they will be slightly different, but there's also the power of an ensemble approach. So if we continue here with the plot heat map function, you will see in R exactly the same as I showed with PyNC view, except that the plot heat map function, it will return a ggplot object. So if you use this package for plotting, and you know that you can add, for example, the scale. In this case, we will set the limits to 0 and 21 degrees. We'll add a theme that we might like. So you can add also labels. You can use this function to plot, but you can still modify. And to come back to the question that was just asked, we look at our plot. And we zoom, then you will see that all the models are different, but they do simulate a similar pattern. Remember that this is uncalibrated, so you might think that the plots are not really good, but these are all with default values. And also notice that Flake is a bit different. It's run on by default with the mean depth instead of the maximum depth. This is an assumption of the model. If you don't want this, you can also force the depth of Flake down by setting one of the model parameters, as I showed before. But these are the default settings. So over here, you see you have run 5 models, and yeah, before LakeEnsemblR, this was actually quite hard to do, to collect all the executables and set it up. And now it's a lot easier to do these kind of things.
And just a point on the output as well is that all of the output is saved onto the same grid. So this, like Jorrit says, allows for this easier pulling in of the data and analyzing it. And as you can see, that the observations have gaps in them, and that the LakeEnsemblR extracts the depths that the observations are, and it makes sure that it outputs modeled at the corresponding depths. So which will allow you to, it helps to facilitate that easier comparison between modeled and observed.
Yes. So we have the plot heat map function to create these type of plots. We also have the plot ensemble function, where you can also set a variable, in this case temperature, and also the depth. So this would create a time series at a certain depth. We also set the argument residuals to true. So if we run this and then run with GG arrange to get 2 plots in one, you will get, for example, this. So in the black dots, you have the observations, and then the colored lines are all the different models, and the gray line is just a simple mean of all the models. And this is to visualize how well your model does. And at the bottom, you see the residuals. So the model predictions minus observations minus the model predictions.
It's modeled minus the observations, right? Because the modeled is less than above.
Yes, you're right. Models minus observations. And then the next lines are essentially the same thing, except now we specify a certain date. And we have added the box whisker argument to true. So it basically does the same, but now for a fixed date. and which will mean that you now see a depth profile for this date. Actually, if you compare with the observations, the fit is actually really bad. Once again, these are default values. And at the bottom, you see that with this sign, sort of where this date is in a yearly trend. So essentially, this is the main use of LakeEnsemblR. You have your settings in a standardized format, and with just a few functions, you can export these settings for all the different models and run them and look at output. We, however, also can add several output variables, such as density. I quickly want to show that there is also a Lake variable dictionary where you see the short names for things you might want in the output. Temperature, I guess, is one of the main things. But now we will add density to the output. So once again, if we are in our ensemble YAML file, we have output and we have variables. We currently had temperature and ice height, and now we will add density to it. So we will run the input YAML multiple function. You can also do this in a text editor, by the way, just add it yourself if you prefer that. So now we have density over here. And then if we run ensemble again, you will see that density is included. And also note that in this line, we have added parallel is true. And what this does is you have probably multiple cores on your computer, and now it will run every model on a separate core. So this will speed up the model run a bit, as it will now be as fast as the slowest model if you have more than 5 cores. Otherwise, it might still take a bit longer. But it will split the tasks over multiple cores in your computer. So it's essentially the same, but now you will get a warning at the end, as Flake and MyLake do not directly output density. So you are not really seeing model output. It's just calculated from model temperature. So it's just to let you know that that's the case, but it will not cause an error or something. And then if we plot it with these lines, P3 and P4. And which are just the same lines as above, but now we have added the var is density over here. So if we zoom, then you see now we have density depth profiles. And what we will do in this section is very quick. As I said, LakeEnsemblR does not really support post-processing of text output, but if you prefer to use this, then this would be a way of plotting it using ggplot. So in this case, we want to plot for the MyLake model the depth, the temperature at 5 meters depth. So we read in the output file for temperature for MyLake and then plot it. So here we would see a plot of temperature, 5 meters depth of MyLake. So I will give you a bit of time to catch up, I guess.
I'm just going to launch a quick poll just to kind of gauge how people are feeling about the speed of the workshop. So if you just answer those, there's just 2 questions.
Yeah, this is something that in a physical workshop, it's a lot easier. As you see on screens where people are guess now we have to do it a bit differently.
But 90% think, Jorrit, that you should keep the same pace. So great job.
If I want
And
to keep
the same pace for the R script. Like, don't speed up, don't slow down. You're doing a great job.
Okay, in that case, I will move on, I guess.
And if everything is clear when you run the code, most people say, yeah, 11 people said sometimes, but nobody said no. So
okay, then I will just continue as we went before. So up to now, we have run LakeEnsemblR with default settings, but usually you will want to do some calibration. And this is what we will do now with the calibrate function over here. And if we go to the LakeEnsemblR YAML file, the last section is the calibration section. And here we regulate what parameters we want to calibrate and between what ranges. And it's important to know that there are sort of two parts in this. The first is MET, short for meteorological variables. And here we can vary meteorological input between upper and lower boundary. So we have, for example, wind speed, which we will now vary between 0.5 and 2. So we can we will see whether the fit gets better by either halving or doubling wind speed. SWR, again, this can be found in the MET variable dictionary, what names to use. This is shortwave radiation. We will vary between 0.5 and 1.5. And then the next sections are for the model-specific parameters. So for flake, we will also calibrate the C-relax-C parameter. These are all variables that are relatively often calibrated in these models. In our vignette, we give a small list of this. So if you are looking for suggestions what to calibrate, these would be some good suggestions. But you can add multiple. If it occurs in the model-specific configuration file, you can add it here. So for GLM, we will use the cof mix hypo variable. If we use a slash, it means that it's in the mixing section, which might help to find if you can give the path to the parameter. For Gotham, K-min, for Simstrat, a siege, and for my lake, the C shelter parameter. And the calibrate function, actually most of these functions work the same. So you have to provide the configuration file and what models you are using over here. But you will also, in this case, have to give num, which is the number of iterations. How many times do I want to run my models to get an outcome? For now, in this workshop, we will use 10, which is way too little to do a proper calibration. I'd say because we will use 3 parameters per model, I would say you need at least several hundreds, but then you are waiting very long, which is not fun for the workshop. So we will use 10 here, but it is too little. And there is also a C method argument, which are the different calibration methods that are supported by LakeEnsemblR, as mentioned by Johannes before. I will quickly write it here. We have 3 options: LHC, Latin Hypercube, MCMC, Monte Carlo Markov chain, which we will be using now. And the last one is mod fit, which is related to the FME package function. So if you want to know more about this, you can run this line. We will not do it now. So we will run the MCMC methods, and we also add the parallel is true to speed things up. Before I run this, if you also want to run this in your PC, this, at least on my laptop, this will take like 2 to 3 minutes. I should say that my Lake, because it's the slowest model, if you have a slow laptop and you're afraid that you might catch behind, you could think of removing it from the list to speed it up, but I will run it with all 5. So because this will take a while, I think this would also be a good time to ask some questions or things like that.
I would just like at this point, I would like to add that also the MCMC method is from the FME package. So if you want to know more about the MCMC, there's also FME function which we use. And I would say for the Markov chain Monte Carlo method, you would probably need at least 10,000 runs. But I guess this is up for discussion, but yeah. So the easiest, or I would say cost-efficient method would be LHC. So I think there you can get quite good results with maybe 500 model runs.
We have 2 questions in the chat. One is from Gosha, and she's asking, are interpolated values used to replace NAs are used for calibration? Do you mean, sorry,
in observations?
NAs in the observations, or I'm quite unsure what she means by NAs. NAs info files. So generally, no, we do not interpolate between in the observations. It only compares actual observations. So we would recommend against interpolating observed values. And yeah, so the model wouldn't, the model does not do that. And then Love asked the questions, is just a general question. Are you, oh, sorry, there's lots of questions coming in. So Love asked, are you planning to add more calibration parameters to the models?
Maybe I can answer this. I think Jorrit said this, but maybe it was not clear. You can add as many parameters as you like in theory. So the framework is quite flexible. So you can just you have to know the name of the parameter which you want to calibrate, and if you add it here in the section which is Jorrit showing at the moment, and you add like the lower, upper, initial, and log argument, you can calibrate any parameter that is in your model.
Yes, so here I'm now adding another parameter for SimStrat, which would be included if I would run the CaliEnsemblR function again. So you can add as many as you want.
Maybe I will just also, there's another question that asks how to choose the parameters to calibrate inside the models. And as Jorrit said, we have in the vignette, there are a few suggestions which parameters we know that have been used in publications and which are quite sensitive. But yeah, sometimes it depends a little bit on your lake, but I guess the suggestions we made work quite well in most cases, I would say.
It is also, I would add to that, it's a slightly different approach because currently, I think this was also the comment at the start, you can spend a lot of time and really tweaking one model to try to get it right. An ensemble approach, you can still do this, but it's also a bit compensated by what other models predict. So you could maybe do a bit less tweaking, a bit less going into depth of every single model, but use the ensemble mean, for example. I think there is still room for some more questions. I just want to show that now the calibration is finished. I also realized that I forgot to say one thing, that during the calibration, if we go to our folder, the Cali folder is being created. You can actually name it differently, but by default it's this. And here we can see, for example, for GLM, if we open it in the text editor, you see that for the parameters that we calibrated, you do different runs, which are printed here. It will start with our default, and then it will do 10 runs. And what it does, it's try to minimize qual, which is a quality parameter. In this case, it's the sum of squares of the error, I think. And then it will look for ways to minimize this, or it will look for the best fit. And this folder is also a way of following progress. So as you see in R, you did not really get a progress bar because that's not possible with these multiple cores, but you could look while it calibrates in these CSV files to see how things are progressing.
And there was another question from Tobias, and he asked if we think about adding more methods for calibration. And I would just like to say to that this modfit method, which we have included here, is actually not one method, but it includes a variable or a very long list of different methods. So this is already quite flexible. So at least I personally, I would leave it like this for now. But there are lots of different methods available here. If you go to the help file for modfit, you will see that there are some, I would say, standard algorithms for optimization in there.
And we also had a question from Shubham Krishna, who asked, can you run MCMC before optimization? And he said, to the best of their knowledge, MCMC does uncertainty estimation.
I would say that you get, so from MCMC, you also get the best set. So you get more than just a optimal parameter set. As you said, I'm not 100% sure. I think, of course, calibration is not like, or not the main thing why people do MCMC, but it's also something you get from it. So you get, along with your optimal parameters, you also get a distribution of the parameters, which is, I think, even more interesting than just getting a single value, because then you can also see if you can get really similar results with a broad range of parameter values, or if it's really just a really thin range, which really produces good results.
And then, yeah, Shajar's question, yeah, so currently calibration is only against temperature. And I remember you did ask earlier about water level, but currently we can only calibrate against observed water temperature.
Yeah, I guess you could manually, but the GLEON function would use water temperature. Yeah. I don't know if there are more questions. I will the next.
There's a lot of
there are more questions.
That's okay. I just want to say, because the next steps are like a little bit boring, maybe. Maybe I can do that while the other workshop leaders can answer some questions. As we have saved the results of our calibration in Cali results, which is over here, it's a list. And for every model, we see the output of the calibration and a best bar. So this will give, again, it's only 10 iterations, so it's not fair. It's probably not the best, but these are the values that we get. And now I'm going to enter these values into the LakeEnsemblR YAML file, which I can show you how to do. We haven't automated this yet, so this would be something you have to do manually. So that's why I think I can do that now, so people that are interested can follow me on screen, but feel free to continue with questions.
Okay, I have, I think, 2 more questions which I saw that we did not answer yet. If I forget something, please just remind me or the others. So Mohammed said that if we have good knowledge of a certain model and we add extra parameters to calibrate this, then this would bias the results, and I would agree with this. So, but I guess the question is what you want from the output. So I think from the the quality measures which we calculate, we can see which model is performing well. And then if we see that one model is performing, really outperforming the other models, then we can think about if this is really because we have really good knowledge about this model and we tweak the right parameters, and this is why it's performing way better than the others, or maybe if this model is more suited to our specific problem than the other. And this is something that then the user has to do if you, for example, want to calculate an average from all of the single models to have a ensemble average, then you could think about somehow weighting the results from the differing models in accordance to their performance, and in this way prevent this bias. But I think it's a really interesting point, and it's not something that is already in there ready-made as a function, and it's really, I think, something that would be a really interesting discussion later on. And I hope this, for now, answers your questions. And then there was another question from Carolina about sensitivity analysis. So I would argue that the MCMC and LHC already are kind of a sensitivity analysis, or you can use the results to get an idea about which parameters are sensitive. But at the moment, we don't have a classical sensitivity analysis in there, I would say. But the ensemble function also has the possibility that you provide a data frame with parameter sets, which you prepared before, and then it will run all of the models for these parameter sets and evaluate all of the models. And with this, you could somehow set up a sensitivity analysis.
But maybe just also to add to that, that the idea was not to look at the sensitivity of each model, but more to look at the result. So to see the uncertainty if you want 5 different models on the same lake. I mean, jump in if I'm wrong, but so we didn't want to really investigate each model. I want to see how the model results differ for one specific site. So it's a bit different approach, I think, for this package right now.
I would kind of agree and kind of not, because I think this is really really a possibility to really compare different models and learn a lot from this. I think both is possible, but it really depends on the question why you want to use the ensemble and what you're interested in. And I think it could be used for both. But yeah, but I think also this is maybe a really interesting thing for the end, for the discussion how we could use this package really.
There was one other question from Atifa, which was asking, if you want to run the model and we have missing input values at hourly step, do you recommend to use daily average and run the model at daily scale, for example? Robert?
Like Tadhg and Jorrit said, I think at the beginning, it really depends on what data you have on an hourly timescale. If you have like irradiation data on an hourly timescale and air temperature and important ones for heat transfer, then you should interpolate to an hourly timescale. But if the important ones are missing on an hourly timescale, you can also use the daily data and just let the model interpolate. And there's currently a question about, for you, Jorrit, what you are currently doing.
Mm-hmm. Yeah. So Jorrit, can you, yeah.
Yeah, that would maybe be a good way of getting back to the workshop. So what I'm doing, it might not seem very efficient. It might be something we want to optimize later, or what you can optimize maybe easily yourself. But we have the results of our calibration, and we're looking for the best parameter. So for every model, we have then our best parameter. Best between air quotes, because we only did 10 iterations, but let's assume this is really the best parameter sets that we have. And I am adding these values in our LakeEnsemblR YAML file. So there is a scaling factors section, which are the scaling factors that can be applied to meteorological input, as described in the comment over here. So then for Flake, our calibration for Flake showed that for Flake, the best parameters for wind speed is 0.15, for shortwave radiation is 0.42, and for C relax C, it's 0.0017. And I'm entering these values for the meteorological variables over here. which in this case differ per model. And I'm also changing model parameters. So now I'm setting up the configuration file to be run with our optimized parameters. And I'm doing this for every model, and I just finished that. So now I'm ready to run export config again and run it, and then we should have a calibrated version of all our models. So I will be doing that now.
And just an important thing to note, if you make edits in your YAML, the LakeEnsemblR YAML file, just make sure to save it. Otherwise, they won't translate.
And these are all comments that we have found out the hard way, of course. Tadhg, Robert, do you think we need to continue with questions, or
We have
continue?
one question from Dale if you have time now. So he, do you want, or should we continue? We have only
course.
two
No.
questions, and if my leg takes some time. So Dale asks if it's fair to run different models with different net data, or is it better to look for consensus among the model calibrations?
This is a very good question. We discussed this during development. It is possible, but the reason that this is not supported by the package is that if you decide that you want to have a common scaling for metrology, we can. It would be fairer, right? Because often you claim in a paper that you calibrate these things because your metrological input might not be representative for your lake. So then to use different ones for different models might not be what you want. But at the same time, using these different values will likely result in the best fit, at least for your calibration period. But if you decide to have the same one, you really need to think, okay, how do I decide what is the best? Because if you take the simple average, let's say we get value scalings for wind speeds of like 1, 1, 1, 1, and 1.5, you could take the average. But maybe the model that gave 1.5, needed 1.5 to get the best fit, is very insensitive. So you would take the average, but then very sensitive models that really need this value of 1 would suddenly give a way worse fit. So what I would advise is then to calculate you have seen in these files, all the model runs that you are done during calibration. So you have all the parameter sets to look at what is the fit for each model, and then try to find at what parameter set do I get the best average fit for all my models. So then you take this partially into account. Then you could fix the scaling factor for wind or shortwave. And then you could, if you want, calibrate again to find for that scaling the best model-specific parameter set. But it's quite a complicated process, and I'm sure there are people that would prefer to do it a different way. So it's not something that we would say always pick the same one or always pick a different one. I think it depends on what you want to use the model for. But it's a really good question. So maybe we can continue with the script. As Johannes said in his first at the presentation at the start of the workshop, an ensemble can be formed by using multiple models, but you can also make an ensemble by using the same model but with different parameter values, or and models and different parameter values. And this is something that you can also do with LakeEnsemblR. So this is what we will show here. Now we will have a hypothetical case in which we add an ensemble in which the light extinction coefficient, KW, is a lot higher. So we make our lake more turbid. This may not be a very realistic case, but if you think about forecasting, you can imagine if you have multiple options for a weather forecast, that you create an ensemble with multiple weather forcings, for example. This would be an example that I could imagine. So what we do now, we set our light extinction in the LakeEnsemblR file to 2, which is pretty high for actually for the lake we're discussing. It's maybe quite all right, but it's set to 2. And then we export again. And then when we run ensemble, we add the argument add is true. So if the default is add is false, then it will always create a new netcdf file. Also, this needs to be run with netcdf. That's important. But if you have the add is true argument, it will be added as a new member in the existing netcdf file. So this is what we do here. So essentially what you need to know is the results of this run are included in the output netcdf file. And we're done. We still have the warning that we get that my lake and flake do not output density directly, but we don't have to worry about that. So if we now run plot heat map, we can change dim for dimension to member. We want to see the member, the different members, and we choose dim index is 2 because our second model is GLM. This will show the 2 different members for the GLM model. So plot heat map, we go to plots. And here we see our 2 different runs, which I guess in this case are not spectacularly different. Here at the surface, we have maybe slightly higher water temperatures than there, but this would be a very simple ensemble with 2 variations of light extinction. And we can run this again, but then with a 3 to see the output for Gotham. So this is how Gotham would look. And I would say that these are actually the key functionalities of LakeEnsemblR. I think you've seen the most important things now. In this second to last section, we will do some post-processing. There are several functions in LakeEnsemblR that will help you with some calculations that you will probably like to do, as I will demonstrate now. But you can also write your own functions for this if you prefer. So you can access all the results in the netcdf file or in text output and do this as well. So first I will show you the analyze netcdf function.
I was just going to suggest maybe we can take, just before we go to the next step, maybe we take a short coffee break.
We still do this one, or we? Because I think it's not that long anymore, and then we would get to the part where we, where you could apply it to your own lake. Maybe that would be a better moment for a break. Yeah.
Okay, that sounds good.
Okay. But if you get vibes that people need coffee, then I get that. It's also fine. So and this part should not be too long. So these are some post-processing functions. If we look at the analyze netcdf function, by the way, we will be looking at the first member again, because the default is that we look at different models for the first member. Just so you're aware. And analyze netcdf, what it does, it calculates some stratification and ice phenology variables. So you have the output statistics. Statistics you will calculate for each model separately, how well it fits. For example, Pearson's R over here. And the second part is what I said about the phenology. So for each model, for each year, if we have for the observations, for the models, You have what is the max temperature, at what day did it happen, what day of the year did stratification start. Don't be put off by the NAs for 2011, as we only ran one day there, so then it gives an NA. But for 2010, you see when stratification started and ended. This might be something you want to calculate. And you only have to point towards the netcdf output, as it's done here. Similar for calcfit. It calculates again the fit, so it's a bit the same as analyze netcdf, but it will also calculate it for the ensemble mean. And this is always an exciting part, because the MCMC calibration function is not 100% deterministic. So if I run it today or tomorrow, I might get slightly different output. If I run enough iterations, it will of course converge, but not. So we can quickly look at the root mean square error for each model. So here it looks like Gotham is 1.66, seems to have done best. Yesterday it was my lake. So that's would be the best model, and actually the ensemble mean is the second best of the different options. There's plot resit, which plots different options with residuals. So it takes a short while. So this is, for example, if you can see it, the distribution of the residuals for each model. So it seems that most models slightly underestimate temperatures. Some other output of plot resit is this. If we can quickly zoom, this would be the residuals over the year. So these are all plots that can help you figure out where is something going wrong with my model, and that might give you ideas on how to improve it. So for example, for actually all the models, you see that in summer it tends to underestimate, and it seems that this happens for deeper locations mostly. So this might give you a thought, okay, maybe I should calibrate something else, or maybe I should check some of my input data. And then lastly, you can use the load var function to get the output data into R from your netcdf file. So in this case, we extract, second, I'm being cold. We extract temperature. We get it into the out variable. So we will have here a data frame for every model for the observations. And because this has the same format as Lake Analyzer once, we can quickly, when we upload the bathymetry, we can do an apply function to calculate Schmidt stability, for example, for all our models. So this is done very quickly using Lake Analyzer. And then if we melt it and put it into ggplot, we get a plot for the development of Schmidt stability, in this case for all the different models in our examples, in our example and observations. And in this part, we will do the same for thermocline depth. We melt, set a column name, we put it into ggplot. And here you have an ensemble of thermocline depth. So this would be also a way of including some uncertainty in a prediction. Usually a model just gives one line, and here you see that there's actually quite a lot of variation between the different models, which is very informative. So this was actually the end of the walkthrough. At the last part, we would, I'm actually not sure how we're doing in the time. We would give the opportunity to apply it to your own lake. This might take some time because you have these exact column headers, but we hope that we have given enough information so you can do this yourself. And the get template function might help you with this if you're not sure how to enter your data. You can have, we have templates in the package. So if you run get template initial temperature profile, then in the files, you will have now a initial temperature profile template that you can look and then change values. So with that, I think I will stop sharing my screen. And as Tadhg suggested, I think it's very good to take a small break. Imagine it's been a lot of information. Maybe get some coffee or some tea, and then after that we can open the floor for questions.
Okay, yeah. So thanks, George. So we'll take a 5-10 minute break. I'm going to just launch a quick poll that you can quickly fill out. So we're going to return in 10 minutes. So at 50 minutes past the 50 minutes past the hour, or wherever you are, and we'll either proceed with maybe either a discussion, or if people want to test out LakeEnsemblR on their own lakes, they can do that. So I'll see you guys in a bit. Okay, so we have a selection of people who have their own data which they would like to apply LakeEnsemblR to. So I'm just going to do another poll just to check whether or not people would like to either we can split up into breakout rooms, and some people can go and into a separate room and work with one of us and get some advice on how to set up for your, or we can have a discussion about future and potential plans for LakeEnsemblR, or if you would like to do both, we could try and come up with a way to accommodate that. But I mean, if you're in a breakout room for that, we can do that as well. And so we have the option then to break up. So I think we have 38 participants that we could kind of maybe break up into breakout rooms that would be led by one of us here, and this would kind of help to kind of allow kind of a bit of more free-flowing discussion. So just, yeah, if you can fill out, answer the poll on your screen. Oh, and also we have not taken a group photo yet. And as is tradition for everyone who's been on these things so far, if everyone could turn on their cameras and get themselves looking as good as they can. I'll take some screenshots. Yeah, I'm still getting the hang of this photo taking. And yeah, as Robert mentioned, you can also tweet with hashtag LakeEnsemblR if you are Twitter inclined. Okay, so I'm just going to take, so first screenshot. And then the second page of people. Okay, thanks very much for the photo. And yeah. So do we have the results from the poll? So we have kind of a mixture. There's some people who would like to go into a room for applying LakeEnsemblR to their own site. And then there's some people who want to do both. So what I'm thinking we could do is we could set up just 2 breakout rooms at the start. So if people just really want to focus on applying LakeEnsemblR, they can go into that room. And then for people who want to just focus on discussion, and then we can try and get the people who want to do both. But if you do go into the LakeEnsemblR breakout room to applying it to your site, there will obviously be discussion there as well. So I'm going to create 2 breakout rooms. And one is going to be called application, and the other one is going to be called discussion. So you should get an option now on your screen on whether or not which one you want to join. So can everyone see that? Has that popped up? This is my first time using breakout rooms. So can you see an option to join a room?
I think you have to put the people into the breakout rooms. At least with me, it says I have to wait for you to assign me to one of the rooms.
Okay, I think that's because you are a co-host. Does anyone else see the option?
Okay, so I now got an invitation to join the application breakout room, as I set. So this is popping up for me.
Yeah.
So this works. I'll be going there.
I'm not seeing anything.
Okay.
But maybe you can just put people that want to go there into the room.
Yeah.
So if you want to go to the breakout room, just write a message to Tadhg,
Yeah.
or just write in the chat.
Yeah, write in the chat which room you want to go, either application or discussion. So yeah, Jim just said there, if you click on the breakout rooms icon at the bottom of the screen, that you might be able to see something as well. I'm not sure if that works. So when you should get an option that should pop up on whether or not to join the room, and yeah. So just click on that once that pops up, hopefully. So has everyone, okay. So is everyone, can you see, did anything pop up on your screen? Tom, did you see anything?
Yeah, I did.
Oh.
Sorry, I was just getting a coffee. We're joining a discussion group.
Okay, so yeah, there should be an option there to kind of click to join the discussion group, I think. Okay. Sorry, the magic of Zoom seems to be a bit challenging. Does something pop up on your screen?
Yeah, it did. And I joined the discussion group and I saw them for a split second and then I got sent back.
You got sent back?
Yeah.
Okay.
I'll try again.
Sorry, I'll try and.
Workshops have been great, by the way.
Okay, good.
Really, really good.
I just, when it comes to breakout rooms. So when you look at the bottom of your screen, do you have an option for breakout rooms? Did you click on the more?
Yeah, actually I do. I've been assigned to breakout room discussion. Yeah, I can join it now.
Okay.
Sorry, I didn't see that.
No, that's okay. If you click,
right.
Yeah, no problem.
I'll click it and
it should send you somewhere.
See you later.
Hello, Warren? Can you hear me?
pick any of them. And Mohammed, maybe it's also good if you do it, because you can use some of those files to look at the column headers that you should use for your own data.
I just wanted to ask, is everyone here in the right breakout room, or did I send someone here by accident?
I should just check that.
Because if anyone wants to move, I can change them to the other room.
We're good.
Okay.
All right. So if you have the
also or have the possibility to look at the water level and calibrate the water level, use multiple inflows, outflows, change inflow and outflow depth. Is there something else you would like to add to that list? Okay, so far it doesn't seem like this. Okay, so we quickly started with this point during the walkthrough, and we said that at the moment, so at the moment, it's not possible, and the main reason for this is that we have 5 different models, and all of these 5 models handle these things differently. So FLake and MyLake don't allow for changing surface water level, and GLM, Gotham, and Simstrat all handle this differently. So the main reason we did not include this from the beginning was actually that it would have been too much work, or we had a lot of other work which we needed to finish first, and so we decided for the first version to really just stick with to waters with constant water level, more or less. Do you want to add something to that first statement, Robert?
So we added like inflow outflow dynamics. We have like this constant water level, so you can do that and add like one inflow term, which then can be balanced out by outflow term. But because we wanted to have like a package for these 5 models, like Johannes said, and Flake currently doesn't have a mass balance, more like an energy balance, heat balance. So it doesn't really consider what goes out in terms of water discharge. So we want to include all 5 models now for the calibration at this stage. So that's why we only focused on temperature. But we see now we have lots of feedback, and people seems to be interested in reservoirs. Nobody knows why. So probably we should include that in the next step. Yeah.
Yeah, I would maybe like to add that it's already possible at this point to do this. So as Jorrit explained, it's possible to go in the specific model folders and change stuff in there manually. So if you know how the 3 models that allow for changing water level work, namely Simstrat, GLM, and Gotham, it is possible to add this and run the ensemble. But I think it's not really convenient, and I see that there could be possible problems with the generation of the compiled netcdf file, because at the moment it's getting the depth at a constant crit, and I'm not really sure how it would work. But me, myself, I'm working with drinking water reservoirs. I'm also really interested in this feature, and I think we could really add this, and now we see that there are people interested, and if some of the interested people would even like to contribute to this feature, we would be really happy.
Yeah, that's a good point. And also about the multiple inflows. I mean, you could just summarize or collect all inflows into one term, because actually for some models you could have numerical instabilities. Like in GLM, if you have like a lot of inflows, they will all have like, can get like an unstable model set up, because they could entrain to different depths, which then have to be resolved. So for now, probably just collect all your inflows into one channelable inflow river.
But in my opinion, I think this would not be the hard part. Did someone want to say something?
Yeah, no, I was just going to cut across there. I just want to make this a discussion. So it's not just Johannes and Robert leading and talking about inflows for 15 minutes. We'd like to kind of try and get input from, yeah, if people have ideas, suggestions, what do they think of the package? So, yeah.
Just regarding first the water level, for me it's very important because and also the multiple inlets and actually the outlet as well. I can combine everything together, the inlets, but in many cases I will have a problem because I have like different salinity. You have hot springs and with high salinity. So if I want to account for that, that will be a problem to merge them all. Specifically, if at one point of time, specific times, there is more outlet than inlets in terms of flow, then actually it's like negative flow. I don't know what I cannot put the temperature of the streams and the salinity because it's only something the model should calculate. So okay, that's something that is maybe not that influencing on the lake, but it's important.
Examples because and ask you later how it was.
Yeah,
It looks like
please.
everything is pretty straightforward.
It should be. I mean, we tried to make it so like with the right CSV, so you get commas and the right column headers, you should get very far. So yeah, don't hesitate to contact us later if you have questions, and maybe just run along with one of the examples now.
So is it not, is the setup not quite the GLM format then?
That's true.
Sort of a hybrid?
Yeah, it's not exactly the same as the GLM format. We picked these rather long column titles so that it's very clear what unit you have to enter and exactly what you have to enter. And I think in GLM also matters what order you put it. It's not exactly the same. But if you change the column headers and make it comma, I think GLM might already be comma delimited actually. But so if you change the column headers to what's required by LakeEnsemblR, that should already go quite a long way. It's just that in GLM, you might also enter your hypsograph inside the config file, while for LakeEnsemblR, it has to be in a separate file. And you can use the get template function to get an example of how you should enter it.
Do you have a working GLM setup for your lake, Jim?
I do, but it's been a while. So, and I didn't have time to sort of bring everything together for the workshop. So I'm going to try it later.
Yeah, no, because this is something that we talked about as well, was kind of writing like functions. So you could take a GLM setup and put it into a LakeEnsemblR, like a translation function. So
yeah, well, and I think the template, just the template generation that you showed is going to be helpful too. So it's nice to have that.
Just to check, did everybody get export config to run? Did you get any errors or?
Yeah, it worked.
Great. So if we assume that you run export config, you should now have these different folders for every model in your folder, which contain the abilities to run that model in that folder. So you're essentially ready to run ensemble and generate this output. I will leave it up to you whether you want netcdf output or
One salinity simulations, you can only run 3 out of the 5 models, and the same will be true for water level fluctuations. So we will only have a subset of the models. So we will add more models to it. Therefore, we also need more people helping with compilations and compiling stuff. Yeah. But you feel free to join. This is like an open project, and we want to continue this at least for 1 more year.
Okay, Tadhg said we will return to the main room in 5 minutes, so maybe we can also talk about the water quality part in the next step, because I think this is especially interesting, and we will also have a sub-meeting in the working group meeting for that, I think. So if you are really interested in this, please feel free to join. I think it's a very demanding task, which is quite complicated. We already had a small meeting and talked about it, and people have different expectations of how easy this will be. But if you have any ideas or things you would like to add, I think now would be a perfect time to just either just talk or type them into chat.
Sorry that this is not about water quality, but it's kind of related of what other people was talking, that maybe you should include other parameters that you can calibrate. And I was wondering if, like, when you are conceptualizing the models across the lake, across all these models, I wonder if there are key parameters that you can aim. For example, I don't know, this is just a simple example. Like lake temperature is very important. That's the one that you are now using for calibration, but maybe you can use, I don't know, not necessarily water levels, but I don't know, maybe like evaporation or latent heat flux, from which you can kind of derive the others. So they can be like a base to derive other parameters. Like it cannot be calibrated directly, but kind of help you to do it. So you kind of have like a general idea of all of this, and then you can derive it so that people can just derive from there what they need. So you don't have like to calibrate like a lot of parameters at the same time, and then you still keep your package like very stable, and like you don't have too much computation time and stuff. Just a comment.
I'm not 100% sure if I understood all of your comments. I think what can be done or could quite easily be added is the possibility to calibrate against another observed variable, for example, ice thickness, which is, I guess, also very interesting. Probably it would be also very easy to add the possibility to calibrate against observed densities, but I don't think that makes a lot of sense. Calibrating against derived variables like heat fluxes or stratification, I think, is a little bit more demanding. But I guess if you're interested in the specific parameter or variable, of course, it makes sense to calibrate against it. But yeah, that would be a little bit more challenging. Maybe someone here has more ideas for the water quality section, because we are really only at the start, and would really appreciate some input here. What you think would be a good approach to start with this?
Hi, Johannes. I'm just thinking of, are you planning on like using the ensemble for the hydrodynamics and feeding that into like a single water quality model? Or are you thinking of running ensembles of water quality models based on a single hydrodynamics? Or maybe even more complicatedly, running multiple hydrodynamic models into multiple water quality models? I guess that's the holy grail, but maybe not the first step. I'm just wondering which of the first two you were planning on first off.
Yeah, that's a very, very good comment. So our idea was, as you said, to start by feeding a very simple water quality model with different hydrodynamic models, because we thought that would be the easiest thing to accomplish for a start. And then I guess once we have done this, the next step could be to really have a ensemble of water quality models, because some of the models we have in here already have water quality models incorporated. For example, GLM has AED, SimStrat also has AED, MyLake also simulates oxygen, phytoplankton, and some more. And for Gotham, we could use FABM to couple it to a water quality model. Yeah.
Okay, that was my first time using the Zoom breakout features, so it was interesting. But yeah, if you guys were continuing something from the discussion, maybe you could kind of bring it back in to include some of the people who are working on their applications. And we can continue on the discussion for maybe another 5 or 10 minutes or so, and then we can wrap up.
Yeah, maybe we can use this also to show the last 2 slides, which, oh, I did the wrong thing. I forbid to share the screen. Okay, I try it again. I have to say yes. Okay, so can anybody see my screen? So those are the last 2 slides. We partially talked about these things already. So we had this question if we want to add more models, and yes, we do. We are in the progress of adding the air-to-water model and ALBM. It will take probably some time, but we're working on it. And if you have your own model which you think would fit in here, and then we can talk and could also include more models. And then I think the big point for next year is really to incorporate water quality, because I think this is really the interesting part, why we are doing all of these hydrodynamics. And we will have a working group meeting at this GLEON conference and ad hoc meeting during the modeling working group meeting. So all of you that are interested, yeah, Robert just wrote, we will also add water level. Yes, of course. We didn't write this on the slide because we were not aware that so many of you are interested in that, but I'm happy because I'm also interested in that. So and we will try to incorporate this as well. And then, yeah, continue with a water quality model. Does someone want to add something? Okay, because otherwise I can go to the last slide where I would like to remind you again about our GitHub and our AmonJ Slack channel. And if you're interested, please use those to contact us, tell us about your problems, issues you have, or features you would like to have added, or if you would like to contribute. Yeah, I think that's it so far from my side.
Yeah, and I would just like to thank all of you also for attending, for having interest in this package. Yeah, it's part of a GLEON project, as you see in the top corner. We have other people who were involved in either writing parts of the code or testing it, and the development went really quite fast. I think we started only last year. So I think this also shows that how far you can get with these collaborative projects. And once again, we're really happy that some of you are interested in this. So yeah, if you plan to apply this package and you will, as was said before, you run into some problems or you want some stuff to add, please don't hesitate to contact us. We're super happy if it's used. That's what we made it for. So yeah, definitely reach out, and I think we can take some questions for the remainder of the workshop if you have any.
One last thing I remembered now that you said that. We are also currently in the progress of submitting a manuscript to environmental modeling and software. So look out for that. Might pop up anytime.
Okay, yeah, so we can kind of, yeah, leave it there. And yeah, thanks very much, everyone, and for attending, and thanks very much to my colleagues Robert, Johannes, and Jorrit for leading this session. It's been, yeah, a lot of work and a lot of effort, but great to see so many people interested. And yeah, thanks very much, and hope to see you all next week during the GLEON meeting.
Thank you.
Goodbye. Thank you very much.